Dear students, most welcome to my YouTube channel. Today we are going to learn aliphatic electrophilic substitution reaction. This is part of M.Sc chemistry's syllabus, second semester, paper CH08 Unit 2. Myself Yunus Rajabek, most welcome you on my YouTube channel. Now today's our topic is aliphatic electrophilic substitution reaction. Before going to the topic, we have to understand what does mean electrophile. What is electrophile? The answer is electrophiles are positively charged species having vacant orbitals. So electrophiles are the reagents which exhibit greater affinity toward electron. These reagents contain vacant orbitals. These vacant orbitals may accept electrons from the species having higher electron density. The examples are H+, R+, NO2+, Br+. These are positively charged species. Whereas SO3, AlCl3, BF3, FeCl3 and carbon dioxide are neutral species. Even though these species are neutral, they may accept electron or lone pair of electron from the other species which are having higher electron density. Now, what is electrophilic substitution reaction? Electrophilic substitution reactions are reactions in which an electrophile replaces other electrophile from its place in a particular reaction. These reactions known as electrophilic substitution reactions. These are mainly three types. The first one is Sc1, which is unimolecular reaction, and the other two are bimolecular reactions. The others are Sc2 and Sc1. Here we can observe front side and back side attack in Sc2 reaction mechanism. Now let's learn what is Sc1 reaction mechanism. In this reaction, in Sc1 reaction mechanism, it follows two-step mechanism. Two steps mechanism. The first step involves bond cleavage and the other step involves bond formation. In first step, bond cleavage takes place and electrophuse leaves its place. Carbonyl intermediate forms during this step of bond cleavage. The second step involves bond formation between carbonyl and an electrophile. Let's see the reaction mechanism. This is the reaction mechanism of Sc1. Here we can see the step 1, in which bond between R and X breaks and the carbonyl forms. Similarly, electrophuse generates here, and in step 2, bond formation between carbonyl and electrophile takes place. So the intermediate is carbonyl. This is the detailed mechanism of an optically active compound. Here the compound has one chiral carbon because it is attached with R1, R2, R3 groups, which may be different from each other, and the hydrogen is represented here by red color, which is abstracted by the base. Base abstract H and carbon anion forms here during the reaction mechanism. This carbon anion flips into other carbon anion, or it converts to the other carbon anion. When these carbon anion takes deuterium from the solvent, these two may form structure 1 and structure 2 respectively. Structure 1 and structure 2 are individually optically active compounds, and we can see here structure 1 is mirror image to the structure 2. If R1, R2 and R3 are different groups, the compound 1 is optically active. Similarly, the compound 2 is also optically active compound. But these two compounds form in equal concentration. There is 50% chance of formation of compound 1 and there is 50% chance for compound 2. So the mixture forms here, and the mixture is actually optically inactive. This type of mixture is known as racemic mixture, in which individual compound may exhibit optical activity. Here we can see another example of Sc1 reaction mechanism, in which in this reaction phenyl secondary butyl ketone is treated with base OD minus, here D is deuterium, and then it is treated with D2O. D2O serves as acid and transfer its deuterium part to the carbon anion, and again racemic mixture forms and the compound is optically active. This one is optically active and this one is optically inactive due to racemic mixture, due to racemization. The another example we can see here, the compound is optically active, phenyl secondary butyl. Here the leaving group electrophilic is hydrogen and the electrophile is hydrogen. H is replaced by H, proton is replaced by proton, but the compound is optically inactive due to racemization process. Here we can see the example in which vinyl carbonate retains its structure, and the retention of configuration occur here. Here in place of Br, CO2H group is we can assign a CO2H group here. Br as electrophilic, as an electrophilic leaves its place and CO2H group takes its place. These two methyl groups situated opposite direction here in reactant as well as in product. Now let's have a look on Sc2 reaction mechanism. This is a bimolecular reaction mechanism, and here front side attack is also possible in Sc2 reaction mechanism. We have seen that Sn2 reaction mechanism follows a backside attack, there is the front side attack is not possible in Sn2 reaction mechanism. Particularly we are talking about Sn2 reaction mechanism. In Sc2 reaction mechanism, front side and back side attack both are possible. In front Sc2 reaction mechanism, so what does Sc2 reaction mechanism and what are its characteristics? Let's see the difference. This reaction follows concerted type displacement mechanism. It is similar to Sn2 reaction mechanism. Regarding to the type of mechanism or type of displacement, it is similar to Sn2 reaction mechanism. In Sc2 reaction mechanism, backside attack is possible, so the inversion of configuration occurs. Also the front side attack is possible. Here we can see the example of front side attack. Here Br as an electrophile attacks from the front side, and it takes the place of HBr, and Br replaces HBr, so the configuration remains same. Here also we can see the retention of configuration. Here we can see this is trans system, and HgCl replaces this group, and this is also trans system, so the retention of configuration remains. Here we can see the backside attack of here we can see the backside attack of Br. Br replaces SnR3. Now let's see what is Sc2 prime reaction mechanism. It is almost similar to Sc2 reaction mechanism, but gives rearranged product. Here the electrophile takes replaces HBr, but it does take the other place here, and one butene is formed here. Now let's see what does mean Sc(I). Here I stands for internal. Sc(I) stands for substitution electrophilic internal. This reaction follows concerted type reaction mechanism. It has four-center electrophilic interchange reaction mechanism. It is almost similar to Sc2 front side attack, which proceeds with retention of configuration. Here we can see the example. HBr, here a labeled HBr replaces these HBr, and the transition state is 4-center 1, 2, 3, 4-centered cyclic system. So dear student, what we have learned today, we have learned Sc1, Sc2 front and back side attack, Sc(I) reaction mechanism. In our next lecture we will see the other types of examples and reactivity and effects of solvent in another video lecture. Till then, bye bye, take care, stay home, be safe.